Okay, so the question is, if the sum of the lengths of the hypotenuse and side of a right angled triangle is given, show that the area of the triangle is maximum when the angle between them is 60 degree. So let us first try to plot what is given to us. So there is, suppose this right angle triangle, let us say it is ABC. Okay, so what is given to me? The sum of the length of hypotenuse. Let us say hypotenuse is equal to x, and side of a right angle triangle, side is also given. So basically sum is given to me, which means that x plus y is some constant which is known. Now what we have to do, show that the area of the triangle is maximum. Okay, so I have to maximize the area of the triangle and see, using that condition, what is the angle between the side and the hypotenuse, right? So anyways, if I have to talk about AB length, then AB length is what? Under root of x square minus y square. Let us keep it here. Okay, now if I have to write the equation of area, then area is what? Area is half of base into height. In our case, the base is equal to y and the height is equal to under root of x square minus y square. Okay, so I have to maximize the area and see what angle do I get. So if I maximize the area, then it is very obvious that a square will also become maximum, right? Okay, so a square will become 1 upon 4, then y square into x square minus y square, something like this, right? So now if area is becoming maximum, then the differential with respect to one of the variables should become equal to 0, right? Okay, but since my original equation which I have right now has two variables x and y, so differentiating will give us complicated equations. What we do is, we use this given data x plus y is equal to c to replace x in terms of y. So basically x now becomes c minus y. So if I use it here, I will get a square is equal to 1 by 4 into y square into c minus y whole square into, sorry, minus y square. Now this quantity is what? This quantity is 1/4 of y square into c square minus 2cy. This is the expression for a square. So if I have to calculate now differential of a square with respect to y, then what will happen? I will have to open this thing. Let us take one more step here. So 1/4 of c square y square minus c by 2 into y cube, right? Let this be a square. Okay, so this on differential will give us c square upon 2 into y minus 3c by 2 into y square. Okay, now if a square has to become maximum, then its differential has to become 0. Okay, so if I take cy common, so it will give me, if I take cy by 2 common, it will give me c minus 3y, isn't it, is equal to 0. Now I very confidently know that c cannot be equal to 0, as well as y should not be equal to 0, which means that the second bracket should become equal to 0, which gives me the value of y. Now y in terms of c can be written as c by 3. If y is equal to c by 3, and if we have this original equation x plus y is equal to c, then automatically x becomes equal to 2c by 3, right? When is this happening? All these things are happening when a square attains its maximum value, because these are the values at which differential of a square is becoming 0, right? So this is what we had to find. So now if I have to comment between the angle between the hypotenuse and the base, I can write the value of cos theta, right? So what will happen here? Cos theta will be equal to base upon hypotenuse, y by x. Okay, but y in terms of c is c by 3 and x in terms of c is 2c by 3. This value on cancellation gives me cos theta is equal to 1 by 2, which means that theta should be equal to 60 degrees. This proves our required result.